Hey everyone, today we're going to talk about hyperbola. So let's begin. What is a hyperbola? Hyperbola is a conic function, like parabolas, ellipses, and circles. A hyperbola is an open curve with two branches, with the intersection of a plane with both halves of a double cone. Although the plane does not have to be parallel to the axis of the cone, the hyperbola will be symmetrical in any case. Hyperbola is also a type of smooth curve lying in a plane, defined by its geometric properties or by equations for which is a solution set. A fun fact is that the reciprocal function, which is f of x equals to 1 over x, is also considered a hyperbola. So, let's talk about hyperbola terminology. In a graph, we have the center, that is the middle point. In this example, the center is located at 2 and 1. The other green dots are called the vertices. The vertices in this example is located at -4 and 1 and 8 and 1. And finally, we have the dotted lines that are the asymptotes. Notice that the two blue arrows don't touch each other, since they are open in opposite directions. Moving to the equation part, there are two types of equations. One part that is x minus y, and the other part that is y minus x. In this example, you can see that the x minus y, it makes the parabola open left to right. And in this other example, the y minus x, the parabola opens up to down. This minus sign determines which direction the parabola will open to. The square root of a and b will determine how much units is the vertices from the center. A and b can be compared to the radius of a circle. However, a will never be equal to b. If there is no number next to the y or x, the center will be located at 0, 0. But if there is, the center will be the same numbers, but with their opposite signs. After changing the signs, the number next to x will be the x value, and the number next to y will be the y value. And now, we're going to learn how to graph a hyperbola. In this equation, we know that the center is -1 and 1, since it's the opposite sign of the number next to the variables. After determining the center, we need to know how much should we walk away from the center. Look at the equation, we see that we should walk 4 units on the x-axis direction to the left and right, since the square root of 16 is 4. And in the y-axis, we should walk 5 units, up and down, as the square root of 25 is 5. After determining that, we have to find the asymptotes. It can be done by connecting all the vertices into a rectangle shape, and then make a double cross in the rectangle's vertices, finding the asymptotes. As we know that the equation is x minus y, we know that it will open left to right. So we dot two parabolas that touch the horizontal vertices, but cannot touch the asymptotes. In this part now, I will show you how to make an equation based on a graph. Let's use this graph as an example. So let's start. Right in the beginning, we see that the graph opens up and down. So we know that we are dealing with an y minus x equation. Now let's take a deeper look at its points. The graph gives us three main important points, A, B, and C. The point C will be the center, located at 3 and -1. So we know that y will be followed by a +1, as it is the opposite of -1, and x will be followed by a -3 for the same reason. Likewise, A and B will be the vertices, 3 and 1, and 3 and -3, respectively. Those 2 points will be helpful to determine the radius of the hyperbola, which is how far is 1 point from the center. By measuring on the graph, it's possible to see that there are 2 units away. Therefore, the denominator of the y is 4. But now, we need to determine the x denominator. And we can do that by looking at the asymptotes. Both asymptotes should have the same slope, and if we measure it, it will give us plus or minus 2 over 3. As we know the slope is the change in y over the change in x, we confirm that the denominator of x is 9, because it's equal to 3 squared. And now we have our equation. Y plus 1 squared over 4 minus 3 minus squared over 9 equals 1. So let's start with our first problem. The first problem asks to determine the center, the slope asymptotes, the vertices, and the direction of the following equation. So I'll give you some time to do it, and I'll be back with the answer.
One eternity later.
So let's go to the answer. I graphed the equation for a better understanding, but you didn't have to do this. So if you were paying attention during the video, you managed to find the center, which was 3 and 3, and the vertices, which was 3 and 1 and 3 and 5. Those vertices were 2 units away from the center, as you could tell by the square root of the denominator of the y. As we were dealing with y minus x equation, the directions were up and down. Additionally, the only new thing that I was asked was the slope asymptotes. In case you didn't notice, the asymptotes in the hyperbola were basically 2 linear equations. So if you see the answer, it's 2 linear equations that have the center as the intersection point. Therefore, the slope asymptotes were minus 2x over 3 plus 5 and 2x plus over 3 plus 1. So let's move to our second problem. Our second problem asks to rewrite and classify the following polynomial into a graphing function. I will give you, as usual, some time to work on it. So let's solve this problem. In this problem, you have to rewrite the equation, and you can do that by using the complete square method. It starts by moving the minus 2 on the other side of the parentheses and grouping the 2x squared with the 4x. After you do that, you should divide the inside of the parentheses by 2 and do the complete square. After that, you have a quadratic equation inside the parentheses and a 2 multiplying on the outside. As a quadratic equation, you can simplify it by x plus 1 squared. And don't forget to add the 2 times 1 on the other side of the equation, leaving you with 4 in total. After all that, you should divide everything by 4 and simplify what you can. And at the end, you have a hyperbola. And it is a hyperbola because you could see that in the beginning the coefficients were different and the signs were also different. So let's do our third and final problem. In this problem, they ask us to write the equation of a hyperbola with the vertices 4 and 3 and 0 and 3, and the slope of asymptotes of plus or minus 3 over 2.
2,000 years later.
This question is a little bit more complicated, so let's start. To answer this question, you should try to find the center first. Notice that the y value does not change, so it's a x minus y equation, thus opening left and right. In order to find the center, you can use the midpoint formula, which will give you the x value for the center. As the y value does not change, our center will be 2 and 3. After determining this, we have to find the denominators. If you see, the question gives us the slope asymptotes, which is the change in y over the change in x. So we know that our denominators are 4 and 9. Now, we just need to put this information on the equation, and then we have it. X minus 2 squared over 4 minus y minus 3 squared over 9 equals 1. Thanks for watching, and I hope you all learned something.
That's all, folks.